All right, let's just get right into it. When you picture Jupiter, what's the first thing that pops into your head? For most of us, it's that classic image, right? A huge ball of swirling gas, the great red spots staring back at us. It's what we all learned in school. Well, what if I told you that entire picture is almost completely wrong?
And I'm not just talking about some minor detail here. This is a fundamental top-to-bottom misunderstanding of the biggest planet in our solar system. The real Jupiter, well, it's a whole lot weirder, way more violent, and frankly more incredible than we ever gave it credit for.
So here's the big twist. Jupiter isn't really a gas giant. It's a liquid planet. And even stranger than that, as you go deeper, that liquid actually turns into a flowing liquid metal. The gas that we see, those pretty clouds, that's just a paper-thin skin on top of something else entirely. Now, to even begin to understand how a planet can be so bizarre, you have to get your head around its sheer scale. Jupiter is heavier than every other planet in our solar system combined, all of them. That immense mass creates pressures and physics that just don't exist anywhere else around here.
Here's a great way to think about it. If the Earth were the size of a single grape, Jupiter would be a basketball. So yeah, it's not just a big planet, it's a behemoth that completely rewrites the rules of chemistry. And for decades, we had no clue what was really going on inside. That is until a random cosmic accident blew its cover. And this brings us to one of the luckiest moments in the history of astronomy. Back in 1994, a comet, Shoemaker-Levy 9, was heading straight for Jupiter. This is an event so incredibly rare. They think it happens maybe once every 6,000 years, and we just happen to be watching.
You can't make this timing up. First, Jupiter's massive gravity had already shredded the comet into more than 20 pieces, like a cosmic shotgun blast. The only problem? All those pieces were going to hit the far side of the planet, totally hidden from us. We were going to miss the whole show. But then, in this unbelievable stroke of luck, NASA's Galileo spacecraft was just arriving at Jupiter and had a perfect front-row seat to the whole thing.
Galileo watched as the biggest fragment hit with the energy of, get this, 300 million atomic bombs. It was, and still is, the single largest explosion humanity has ever witnessed. A little while later, as Jupiter turned, the Hubble telescope saw the bruises. Gigantic, dark scars in the clouds, each one bigger than our entire planet.
These impacts were so powerful, they basically kicked Jupiter's guts out into space in these enormous plumes of debris. And Galileo flew right through it all, giving us our first ever taste of what's under those clouds. The most shocking find? Water. A ton of it. This was so out of left field that it launched a whole new mission called Juno just to figure out what was really going on inside this place. So, let's do it. Let's take what we learned from that collision and from Juno and take a journey deep into Jupiter, layer by strange layer.
We'll start at the top, in the only layer we can actually see from Earth. These beautiful swirling bands are clouds made of ammonia. But here's the thing, it's not really a weather layer so much as a weather skin. It's only about 50 kilometers deep on a planet that's 140,000 kilometers wide. And the weather in that skin is just wild. It's colder than minus 100 degrees Celsius, but there's still liquid water, because the ammonia acts as a kind of cosmic antifreeze. This mixture fuels these massive lightning storms and creates slushy hailstones made of ammonia and water. Scientists actually call them mushballs, that plunge deep into the planet.
And the Great Red Spot? That thing's a storm so ridiculously tall that its peak literally pokes out above the main clouds, soaking up more UV radiation, which gives it that reddish color. We're talking about a storm that's taller than Mount Everest and deeper than our deepest ocean trench. It's just a completely different scale. Okay, so let's descend, down below the clouds. As we go, the crushing gravity starts to squeeze everything. The pressure skyrockets, and so does the heat. The air, which is mostly hydrogen, gets thicker and thicker. Like a fog so dense you can't tell where the gas ends and the liquid begins. It just becomes liquid.
And right here is where you'd find it, the single largest ocean in the entire solar system. It's a 20,000 kilometer deep ocean of pure liquid hydrogen. But here's the mind-bending part. On Earth, you need extreme cold to make liquid hydrogen. On Jupiter, the pressure is so intense that it stays liquid at over 1,000 degrees Celsius. So, we're officially out of the gas, we are now deep inside a boiling hot, liquid planet.
But hang on, because the journey gets even weirder.
As we sink deeper into this superheated ocean, the pressure builds to millions of times what we feel on Earth. And that's when things go from strange to straight-up alien.
Under that kind of pressure, something incredible happens to the hydrogen. The atoms are squeezed so hard that their electrons are literally popped right off. These free electrons start flowing through the liquid, which means all of a sudden, this liquid hydrogen can conduct electricity. It has become a new state of matter, metallic hydrogen. You know the liquid mercury in an old thermometer? Picture that. Now imagine an ocean of that stuff, a flowing, conductive liquid metal that's 40,000 kilometers deep and makes up most of an entire planet. That is the real Jupiter.
So what's at the very bottom of this insane metallic ocean? Well, for decades, we just assumed it was a solid core of rock and iron, like a normal planet. But what the Juno mission found was anything but normal.
The old theory was simple. It was neat. A solid core about the size of Earth. But the new discovery shows the core is fuzzy. There's no clear boundary where the metallic hydrogen ocean stops and the core begins. Instead, they just kind of blend together into this enormous, dense soup of liquid metal, rock, and ice.
And this, of course, raises the $1 million question for all the scientists studying this stuff. How on Earth, or on Jupiter, does a planet's core get so fuzzy? The leading theory is absolutely wild. It suggests that early in its life, Jupiter got hit by another planet, one 10 times bigger than Earth, and the impact basically scattered its original core. But there's a problem. When scientists model this on a computer, the fuzzy core quickly settles back down into a solid ball. It doesn't stay fuzzy.
Which leaves us in this amazing place, scientifically. Our newest discoveries have totally shredded the old textbooks. We know for a fact that Jupiter has this huge, bizarre, soupy core, but we have no good explanation for how it formed or why it's still like that today.
And that is what makes Jupiter so exciting right now. In just a few years, it's gone from the planet we thought we knew best to a giant liquid metal mystery box right in our own cosmic backyard. It just proves that even after all this time, we're just scratching the surface of what's out there. And it really makes you wonder, what other unbelievable secrets are the planet's hiding?